Oh, wait, let me say this also. Monday office hours, I did post an announcement, but unfortunately, I think they're going to be canceled for the rest of the semester, mostly because I have to go to campus each week. Well, I'll say it, to get tested for COVID. You know, it's just something I'm doing. I mean, I thought it was like appropriate considering this pandemic. But again, if you need to reach me, you know, don't be afraid to email me and stuff. I mean, if I have free time, I can always meet with you through Blackboard if necessary. I'm more than willing to help you. Okay? All right. Okay, so let's go through this one together. So here, as you can see, what we have, okay, is an absolute value equation, okay? So we're going to have a solution to solve, at least one. For one thing, this is when the inside equals 8, right? So again, we want to solve that equation first, right? We're looking for x such that the inside is equal to 8. So what do? We subtract 9 from each side. We have -3 times x is -1, as you can see, right? Because we subtracted 9. We're dividing by -3, and we get x equals 1/3. Okay, so that's one solution, right? If you replace x by a third, okay, if you replace x by a third, you would get inside here 8. And the absolute value of 8 is 8. But are we done yet? No, we're not done yet. Because remember, we have another solution to solve, right? We want to know when it's equal to -8. Because when the inside, when -3x plus 9 is -8, we also have absolute value 8. So we have this equation to solve as well. -3x plus 9 is -8. You can see it's actually the same steps. Of course, your answer is going to be different. But this is what we get. So we subtract 9 from each side. We have -3x is -17. And so again, we divide. And we get 17/3. So that's another solution. So our two solutions then is, oh boy, what is it? Hey, where'd you go? So we get two solutions, right? We have 1/3 and 17/3. So 1/3 and 17/3. Those are the two solutions, okay? So you have two equations to solve for this. Okay, good. All right. Are there any questions about this example, I mean?
Why did you make the 8 negative?
Because you have two equations to solve. Here, let me do this. Because when you have the let me go back to that slide. If I can find it. Here, because when you have this kind of equation to solve, the absolute value of something equals a number, b, right? B is a number. You want to solve when the inside is b and when the inside is -b.
Okay, I get it. Thank you.
You sure? Okay, you sure?
Yeah.
Okay, just wanted to be sure. It's good, very good question. Okay. Let me see something actually. Okay. All right, here's another one, I think. Yeah. Okay. So, okay, that was good. Okay. So now we want to solve this inequality. And again, we have absolute value here, right? That's why we solve this compound inequality, right? We have it's less than or equal to 6. So the way you solve absolute value less than or equal to a non-negative number, you solve this corresponding compound inequality, as you can see. Now that's what I'm doing here. And again, you want to get x all alone. That's what you want to do. So what am I doing? What I did was I subtracted 5, you know, from all 3 sides, I guess, as you can see. And what we get is 7x we get in the middle, right? The 5's gone. We have negative 11 on the left, and we have 1 on the right. Then I divide by 7. As you can see, when you divide by 7, what happens? Well, we get negative 11 over 7 on the left. The 7's cancel, and we get 1 over 7 on the right. And again, since 7 we divided by, right? 7 is positive. We don't turn the inequalities around. If you, for some reason, did, what would happen is you would have negative 11 over 7 greater than or equal to x, greater than or equal to 1 over 7. But that doesn't make sense. Hence, we don't turn them around. So we have this. So I graphed the solution set. But as you can also see, the actual solution set is a closed interval. It's all numbers between negative 11 over 7 and 1 over 7. We're including the endpoints as well. Okay, for the last one, let's do this. I want to do this one together, mostly because we're getting low on time. Okay, so here, what we're going to do is solve this inequality. It's similar to the one we just did. Of course, the numbers are different. And we also have strict inequality, so these circles should be open. Okay, let me see if I can fix that quickly. Oh, geez. All right, hold on. Okay, so it should be open circles, and that does, okay. Let me just go. And also this should be open. There we go, now I'm happy. Good. But this is what we get here, as you can see, right? So as you can see, we have negative 4x plus 12. We have to solve it less than 10, but also greater than negative 10. And it turned into greater than or equal. Oh boy. All right, but anyway, let me go through the steps at least. So basically here what we have is negative 4x is in it. We subtract 12 from each side, right? As you can see. And then, of course, we get negative 4x is less than negative 2, greater than negative 22. That should be strict inequality. I'll fix that shortly. Then we're dividing by negative 4, right? So we do turn the inequalities around. You have to, right? Because you're dividing by a negative. And so altogether, we get x is strictly less than 22 over 4, which is 11 over 2, but you can leave it as 22 over 4. And x is greater than 1 over 2. Notice that they do become positive because you're dividing by negative. You're dividing by a negative. So we get our solution set as this. Let me just see if I can fix that quickly. I hate leaving it like this. Well, at least I'm able to do this. Okay. All right. And I'm sorry for those, mistakes. So, but hopefully you still can understand what I'm doing. So, does this make sense? Yeah, I hope it does. So, let's see. I don't know if I can really, well, I guess I can mention the next section. Let me just start the next section real quickly. 2.1 here. All right, let me just share that. Here we go. Okay. All right. Okay. But here, what we're going to see in 2.1, so just like the other sections, I'm not going to cover everything in chapter 2, just the most important stuff. We're actually going to see, or I guess remind, because I'm pretty sure they teach it in high school, at least I hope they do, what the Cartesian plane is, the XY plane, in other words. Again, you draw, that's the plane that You can draw graphs in, it's used in not every math class, but in a lot of math classes. It's also used a lot in the other sciences. When you have an equation in variables X and Y, and they ask you to graph it, or you graph it for whatever reason, you're graphing in the Cartesian plane. Then we'll see the distance formula between 2 points in the Cartesian plane. And that distance formula is actually based on Pythagorean's theorem. You'll see what I mean when we do it next time. We also have the midpoint formula. In other words, any 2 different points in the plane, you can connect them by a straight line. That's something you can do. I'm not sure if that's an axiom or if you could prove that, but either way, you can do it. And then the midpoint formula gives us the point on that line segment halfway between the 2 other points. I mean, that's what we're going to see next time. So it's 12:50. I don't want to keep anyone here after 12:50. I don't think that's fair. So because of that, I guess we'll stop here. Okay. So I'm probably going to start from the beginning of 2 next time. So, okay. What happened? Okay. Is the test posted? The test will be available today at 3. I just made an announcement for it. Well, although the announcement you won't see till 3. You will be able to see it in the content section. There'll be a folder there called exams. So if you don't see it, just let me know and I'll help you find it. Okay? Okay. And it will be due on Thursday before midnight. So you have some time to do it. Okay. All right. Okay, so I guess that's it for today. So, if you don't see the exam, don't be afraid to email me. See you guys.